Okay, so here's another example. Secant theta equals 5. They tell us the sine of theta is greater than 0 and that theta is between 0 and 2 pi. Once again, they want us to be able to calculate both double angles for sine and cosine and both half angles for sine and cosine. Alright, let's just do some of all of our background work first, collect all of our information. Let's start with this secant theta equals 5. Well, looking back at all the formulas, what trig functions do they involve? Sines and cosines, right? So it's better for us if we just kind of look at things in relationship to sine and cosine. So if secant of theta is equal to 5, what is the cosine of theta equal to? The reciprocal of this, which is 1/5. So good job about that. All right, which that is also known as your x value over your r value, right? We're working here, but we also want to be where the sine of theta is going to be positive. So that's what this means. Greater than 0 means the sine of theta is positive. So all students take calculus. Let's remember that. All trig functions are positive here. Sine and its reciprocal function here. Tangent doesn't really look like a t. And cotangent here. So tell me which two quadrants are we working with? This tells us the whole unit circle. But what does this tell us? Either this one or this one, right? So automatically I know I'm down to these two. But what about secant? If the cosine of theta is positive, right? There's all positive here. So where is cosine of theta positive? Only in quadrant 1. Good. So basically we use that information to figure out, I'm going to rewrite this so it's not so big, which quadrant. So that puts us in quadrant 1 that satisfies all of those conditions. Now this is our x value over our r value. So if the x value is here and our r value is 5, what are we doing here? Finding our missing side. So pause this and do Pythagorean theorem and then check your answer. Okay, after doing some work on that, you should have come up with plus or minus the square root of 24. Or if you simplify that, because remember 24 is the same thing as 4 times 6, right? That's 24. And the square root of 4 is a 2. So you can see how that comes. So you can use either one, but you may want to use the simplified version. And it's going to be we have to choose positive or negative, right? Well, is this value going to be positive or negative? Yeah, it's positive, so we're going to use the positive value, 2 square root of 6. Now, we pretty much determined all of our sides. For this formula, for all of these formulas, we end up needing a sine of theta, and we need a cosine of theta value. Okay, so what would be the sine of theta based on this? It's your y over your r, so it's the square root of 2 square root of 6 over 5. And what about your cosine? We found. But we can also look over here, your x over your r. It should be consistent. So we're going to use these two values in all of your formulas to get the solutions. So for part A, you're going to get the sine of 2 theta. Part B, cosine of 2 theta. Now we worked through a couple of these, so what I'm going to do here is I'm going to write them down and I'm going to give you the solutions to them. So this is just going to be an extra one that you can work with to see if you can get the correct solution. So just do the algebra basically. Cosine of theta over 2. I want you to find both double angles and half angles. When you simplify your answer, you should get 4 square root of 6 divided by 25 when you calculate that one. For part B, you should get negative 23 over 25. This one you should get 2 times the square root of 1/10 and square root of 15 over 5. Quick reminder though, don't forget to figure out the signs of these based on the location in which quadrant it is, the location of theta over 2 of the half angle. Okay, let's look at one more together in which I'm going to help you collect all the background information we'll need to be able to plug into these formulas, but because of the sake of time, we're not going to work through all of them. I'll do like we did on problem number 3, but I do want to work with you determining what quadrant we're in and finding all of our missing sides and then determining the sine of theta and the cosine of theta that you will need to plug into these. So pause this and see if you can determine your quadrant first of all. Okay, let's just look through this. All students take calculus. First of all, I'll remind myself this is where our trig functions are positive. So this just tells us we're on the unit circle because it's between 0 and 2 pi, so that doesn't restrict any of the quadrants. When we come here, secant of theta is less than 0. So I just want to make a note that secant theta less than 0 means that secant of theta is negative. Okay, now secant of theta is positive here because cosine and its reciprocal here. So it's positive here and positive here. Our problem tells us we need our secant to be negative. So which ones can we mark out? We can mark out here and here, right? Because secant's positive here and secant's positive here. So I automatically know I'm going to be in one of these. The other thing I need to do is look at this. This tells me my cotangent of theta is negative. So cotangent theta equal negative 12 tells me that cotangent theta is negative. Okay, well, cotangent of theta is positive here. So where's the only place that it's negative that's left? Yeah, quadrant 2. So we have determined that we are in quadrant 2. It's probably one of the more challenging things about this problem. And we also know that cotangent theta is equal to negative 12. What's the cotangent theta defined to be? The cosine over the sine or the x over the y value. So if I put this over a 1, x is negative 12. Y is positive 1, and that makes sense because if we go to the left on the number line we get negative, and if we go up we get positive. So now what we need to do is just use Pythagorean theorem to find our radius, our missing side. So pause it and try that. Okay, we're going to come put that in plus square root of 145. Okay, on this next page, I'm just going to put the solutions just like we did previously. So once you calculate sine of 2 theta using the formula, you should come out with the answer negative 24 over 145. Okay, so I want you to try these on your own time. B is going to be cosine of 2 theta. And when you evaluate this, you should get 143 over 145. The half angle of sine is just going to be positive 145 plus 12 square root of 145 over 290. And our last one, cosine of theta over 2, it's going to be positive, what do you think? 145 minus 12 square root of 145 over 290. Okay, what I want you to note about these, note theta over 2 lies in quadrant 1. These two right here. So remember when we found this, our angle was in quadrant 2, but that was theta. Then if we did theta divided by 2, then that fell in quadrant 1. Well, what about the sine value in quadrant 1? Positive. What about the cosine value in quadrant 1? Positive. So make sure you are remembering to do that.